Good afternoon, folks. I'm happy to be here and to present you something which I find very interesting and which gives hopefully a different perspective on what we can do with machine learning and all the new stuff which is emerging with data. To start with, I want to ask you if you have ever thought about what Amazon actually earns by having recommendations on their site. It is reckoned that they do about 1/3 of their sales based on the recommendations which they have on the site. If you look at Netflix, about 80% of the videos they play out are based on recommendations. And I was wondering how did those companies actually start before they implemented all these sophisticated and different kinds of analytical models in order to improve and get to these levels. And what we have at the moment, what they are focusing on is session-based recommendations, so they get really to the second and the point where people are in that particular moment in order to play out recommendations. But what they did do when they started with it, they calculated it randomly. Yeah? So I found this interesting, that they first checked whether the idea of getting a recommendation is actually worth having before they actually implemented a lot of sophisticated algorithms. And this is basically what I want to get over today, that before you start with complicated algorithms, try to figure out what is the actual customer problem and create a baseline. What does a simple heuristic actually provide to you and which kind of customer value it actually provides? And only when you have confirmed that a particular data problem can be solved with data, then invest time in that difficult algorithms. To get you why I'm here and what are we doing as a company, we support companies implementing sophisticated data science problems. So we have a number of data engineers in our company, we have a number of data scientists, web developers, operational guys, all these kind of things. And this is one of the examples. It's also a company which is situated here in Berlin. Mobile.de, an online vehicle marketplace. So every time you're searching for a car and you get recommendations on that page, the engineers which are working for us have been implementing this. To start with, I want to give you a brief overview what I understand as a data product. I differentiate these 3 different types. So I like very much that we have this categorization in order to give decision makers an idea of what they can expect from the type of product we're actually doing. So I distinguish between the products where I sell the data directly. This is something as a weather service where I provide this kind of data and I get direct return on investment or some sort of revenue based on the quantity of data I'm selling. Then we have this, which I find very interesting, this type where I have an original product, I enhance it with data, and I sell more of that original product. I like very much the Tesla example, where they have they collect all the data when you are driving and you're switching on the autonomous driving feature, and you get all the time, you correct that autonomous driving feature. They call it fleet learning. They collect that data in order to improve their algorithm. So the time people are using that autonomous driving feature, Tesla improves its own algorithm and gathers more data of which kind of service they can offer. So this basically improves the sales of the cars, basically. And the last thing is this is more the traditional part, when you use data in order to have insights to then improve something else. In this particular case, Reckitt Benckiser used the Google flu data in order to know in which areas of a particular country a flu broke out, some illnesses broke out. Then they combined this with their own marketing data, some spreading algorithms, and then they knew, okay, when a flu breaks out here, then in 2 days the flu will be somewhere else. So they could put put advertisements and marketing in that place where the flu will be in 2 days. So they could focus somehow their marketing planning. Knowing which kind of data products there are, and we know that there are quite a lot, so lots of companies, and you probably work for some of those companies, are implementing these kind of data products. The question which we want to ask is how we do actually discover one. And the approach which I like very much is to start with a value chain analysis, to look what do people actually do with the product which I'm offering. And I brought to here the example of the runner, and we were thinking, okay, what does a customer do? So let's assume the customer is in this situation. He wants, shall I run or not? Which kind of, how often shall I run? What should be my workout plan? What should be the course which I'm running? Then he's running, then he recovers, and then he gets back to course selection. So what we suggest is to look at the different jobs which a customer has, and then look where does my product actually fit in, but look also at the parts which are before using my product and after that. Yeah. So the classical Adidas or Nike would just look at the selecting a runner piece of the value chain and not so much at the other pieces. And if you now want to know in which places could a data product actually take place, we look at the variance of the decisions we make in each of these phases. So we look at the best cases of the decision which can come out and the worst cases. So let's say in this case we have this deciding to run. We say, okay, if I decide to run, I expect that my stamina improves or that I get better weight management, this kind of things. Or in the case of the course selection, I expect the course to be motivating, so I continue running. And the worst case might be when you decide for running, you die, yeah, because you get a heart attack during a run, yeah, for example. Or the course, in case of the course selection, it's simply demotivating. And if you look at this from a decision point of view in each of these steps, you get an impression where data could help you. You can look how often is this particular decision made, yeah? In case of the first one, deciding to run, it's basically one thing. And in the course selection, it's a decision you make every time you're running. That can be 3 times a week. Even so, the value, let's say the difference between motivating, demotivating is not so high as between death and no death. It's still more often. So if you multiply that somehow, you get an impression at which points within the value chain data which supports the decision to come from the worst case to the best case might be worth something. So that's what I'm suggesting. Look at these different outcomes, look at the difference between the best case and the worst case, and look where could data actually improve that decision in order to come from the worst case to the best case. And if you have done this, you can hypothesize which kind of products can actually help you. And it's working again. If you look at that particular running example, you see that there have emerged a number of services which actually support that decision. Yeah, you have Strava, for example, which collects all the information from people who are running, highlights on a map the different courses which people have been running, and so gives you an indication where you should run. So you see that a data product has that particular value proposition to support that decision. And now you can look with the data in the past, how often have people using that particular track. You can look at the present, who is running at the moment at that particular track, what is your current heartbeat and how exhausted you are. And you can look in the future, which kind of courses should you run in the future. So this is something you can derive a value proposition for your product from. And you can also say, you can take this also to for your organization. You can say, I have a particular organization, some people who are caring just for the master data to give you a very good sense what is going on. And then you can have some specific products and teams who look at the transaction data and produce, let's say, the recommendation product. Now, having defined a particular value proposition and you know which kind of problem you solve for your customer, you can look at the value chain, of the data, not so much from a customer perspective now, but from a data point of view. Do I obtain all the data? Do I create all the data? Which ways of creating data do I have? Do I store that? Where do I store that? With which other data can I integrate it? Which kind of analytics methods do I use? Which kind of algorithms? And how do I present it? In the case of bots, you would even go so far that the bots takes over some action for you and then deals with the data for you. But in the case of defining your product, you should then care, how do I integrate the interaction of the user back into my algorithm? All of you who have dealt with machine learning algorithms know that you need the feedback of the user if your prediction was right or not. And the better you design your product and the better you nudge your customer into giving you feedback if your prediction was right or not, the better you can adapt your algorithm and learn more. In the case of the recommender, as we have implemented for mobile.de, we use each selection and each search in order to obtain a better perspective what the user actually wants, which car he actually needs. Is he more the transporter guy or the sports car guy? Does he like black or white cars? And so we can suggest cars which fall in a similar category. And another perspective is everything in the value chain can be copied. You can copy the design, you can copy the algorithm, you can copy even the master data. What people can't copy, and what is probably also the reason why Google is still so dominant, is you get the transaction data of each user. This is something nobody can copy, and that is information which only belongs to you. So this can create you the USP which you need. And to give you an example where in particular Google used this, is the reCAPTCHA service, where they identify, probably most of you know reCAPTCHA, where they use these particular images of houses in order to identify if people are humans or not. But they also improved their maps feature by identifying the different pictures and numbers in order to assign them to houses within their maps feature. So and we have defined this data value matrix, as I call it, in order to give you a small categorization and a possibility to look at these different data products which you might have defined in order to categorize them somehow. So we say we start from an aggregation level and go up to the machine learning level. So we say some data products are very easy. They're just sums of aggregations or something. While we have on the other axis, we have this perspective, which service does my data product actually improve? Is it something which I include on my original product, or do you use it in order to create another product? Yeah, let's say in the reCAPTCHA case, we have that service which is for free to identify if a human is a human and not a bot. And we use it in order to improve the map service. And there, the quality of the map service gives you details or improves your advertisement revenues, basically. So this metric somehow supports you in finding data products and also define a roadmap how to improve your data products along the way. Yeah? So you could start by something which is improving your original service with just a simple aggregation, add some machine learning, and then if you collect all these different data, you can look at other companies which might obtain that data. Again, start by an aggregation, and then maybe in the long run you use machine learning to sell that to other companies. So to sum up, I say start with the customer. Look at what the customer actually needs. In which situation is that customer, and how is that integrated in a particular value chain of that customer. And then if you have that value chain of the customer, by looking at the best cases and the worst cases, you can know, is that a decision problem which data can actually solve? And if it's a problem which data can solve, you can build a number of hypotheses how you present that to your customer. Then you can test it with a simple algorithm, as Amazon did with the random case, and see does that actually improve something. Yeah, if you have defined a KPI like NPS or click-through rate, you can see if the customer actually uses your data product. And only then you should improve based on sophisticated machine learning algorithms. And then you will find after some time that the data which you're generating might also be helpful for somebody else in a completely different service. So you can differentiate between the two to improve your service, and on the other side to sell to somebody else. And if you have done all that, close your feedback loop in order to obtain a USP. And that's what I wanted to tell you today. And if you want to discuss that with me longer, you can find me upstairs on the 3rd floor. Thank you.